Good day, class. You're welcome. In our previous class, we had a revision test, and I discovered there are many mistakes in the work you did. So I decided to have this video for a revision. We're going to have a quick revision on laws of logarithms, okay? And the very first law we know that is this. If I have log x base a plus log y base a, it is the same thing as log xy base a, both of them, right? Multiply together, base a. And then when we have log x base a minus log y base a, it's going to be log x over y base a. We have proved these formulas already, these laws already. Then n log x base a is the same thing as log x power n base a. This is just very simple. Okay, we have proved these things already, these laws already. And then the two special laws are log 1 base a is 0, log a base a is 1. These are two special laws that we have proven already. Everybody is going to be conversant with this test. That's the only way you can enjoy it. Okay, be used to the laws, know them by heart. Okay, now we're going to take some simple examples. The first one, number 1, find the values of this. We have, just by sight we can be able to tell the first answer. Okay, the first answer, a. See, let's take a solution here. Solution a. This is log 16 base 2. Okay, by sight we can be able to tell the answer. Just ask yourself this question: 2 raised to power what will give me 16? It's 2 raised to power 4, and so my answer is 4. But I don't want you to solve it this way. I want you to express 16 first as an indexed number. 16 as an indexed number, so it can be written as log 2 raised to power 4 base 2. This is what I expect from you. You write 16 as an indexed number, so this is the indexed number representing 16. Of course, 16 can also be written as 4 raised to power 2. 4 raised to power 2 like this, okay, is equal to 16. Can write it like this, but I choose 2 raised to power 4, which is also equal to 16, because it will suit this. It will fit this base. Okay, all right. Now, if you look at this, the next law that you should be looking at is the third law. Okay, it is the third law that is applicable here. You see, if I have log 2 raised to power 4 base 2, this is my n now. So this 4, this is my n now, right? This 4 is going to be a base here. Sorry, it's going to multiply the logarithm completely. So we're going to have, using the third law, this law. Okay, so I'm going to have what? Quickly, 4 log 2 base 2. But again, if you look at log 2 base 2, you will notice that it is a special logarithm. How? Look at the special logarithm, log 2. Okay, the special log 2, we have log a base a is equal to 1. If I have log a base a is equal to 1, it means that log a number to its base is equal to 1. So that means that if I have log 3 base 3 would be equal to 1, log 4 base 4 is equal to 1, log 5 base 5 is equal to 1, log a base a is equal to 1, and so on. So now we have log 2 base 2 is equal to 1. That means that 4 times 1, which is equal to 4. Yes, so that's what we're going to have, right? Somebody can do this by sight. By just looking at it, you know the answer should be 4, because 2 raised to power 4 will be 16, and so the answer is 4. All right, logarithms are powers actually connected to the base. B, what is in B? We have log 27 base what? 3. This should be written as log 3 power 3 base 3. Okay, notice the way I write my logarithms. Some of you write logarithms like this. See, I saw it in your work. Like if I write log x base y like this, somebody will write it as log x log y like this. Then they will write x here. How? That's wrong. Okay, this is not a power. All right. Okay, so now this is a power. 3 is a power here, but notice 27 isn't a power of 3. 27 is not a power of 3. It is log 27 base 3. All right, that means now we can have, using the third law again, we can have 3 multiplying the logarithm to give us 3 times log 3 base 3. And so log 3 base 3 would be equal to what? 1, which is now equal to 3. 3 times 3 is 3 times 1 is 3, right? Then C. In C, what do we have in C? We have log 256 base 4. What number will I raise 4 to give me 256? 4 is power, what is 256? So I can write 256 as an indexed number now. So I'm going to have log 4 raised to power 4 base 4. And so this becomes 4 log 4 base 4, because this 4 will multiply this using the third law again. Don't forget it, using the third law, right? And so we can have this is equal to 4 times 1, because log 4 base 4 is 1. And so we can have 4. My answer is 4. All right. Next one, D. D, we have log 125 base 5. 125 can be written as an index number as log 5 raised to power 3 base 5, which is the same thing as 3 log 5 base 5, which is the same thing as 3 times 1, which is equal to 3. I'm sure by now this is going inside very well. You're understanding this very well. E. In E, we have E and F. There is some difficulties here. We have some difficulties here, right? There are some difficulties here. For E, we have, let's see, let me write it quickly. Log 32 base 4. All right, first, let me write 32 as an indexed number. So 32 should be written as log 2 raised to power 5 base 4. And so my answer is 5 log 2 base 4. Okay, I am not going to solve this the way I solve this. I cannot have 4 here. So the only way I can deal with this is to think of this somehow. What number will I raise 4 to give me 2? Easy. You know that it's half. 2 raised to power 4 raised to power half is equal to 2. 4 raised to power 1 over 2 means the square root of 4, which is equal to 2. So that means that this should be half. Log 2 base 4 is half, because 4 raised to power half is 2. And so I'm going to have 5 times half, which is equal to 2 whole number 1 over 2. Okay, I'm going to derive something more important called the change of base. I'm going to do so later. We're going to be solving this, because at this point it is difficult to have a number to its base here, right? A number to its base is difficult. So at this point I will just stop with number 9. Number 9 can also be solved this way. Number 1f can be solved this way, but I will use change of base to solve it, which I'm going to do in the next video. Okay, I will show you change of base in the next video, but before then, let's just solve f. Log what? 27 base 9, which is equal to log 3 power 3 base 9, which is equal to 3 log 3 base 9, which is equal to, what number will I raise 9 to give me 3? Is half. 9 raised to power half is 3. And so the result here is half. 3 times 1 over 2. And so we can have 3 over 2. All right? Which is equal to 1 whole number 1 over 2. 1 whole number 1 over 2. All right? That is what we have. Okay? In our next video, I'm going to show you change of base where I can conveniently use it on these types. Okay? These types. I'll conveniently use it on them, and then we get our answer. Okay? That's the next thing I'm going to do. Thank you.